Hello everyone, this is continuation of Sudokuvania, Digits of Despair. This is a long series, partly because I messed up, so I had to restart anyways, but I kind of messed up my, um, actually, I don't know how to describe it. Like, my cookies somehow got messed up, and then I wasn't able to get actually a website from anything, so I had to clear my cookies and cache. I clear my data essentially for the past week, and it reset everything here. So, anyways, let's continue. Um, this is 8 and 4. Okay, where were we? We were looking for. Okay, so I think I completed all of this first. So the two has to be one of these. Um, hmm. 6 is one of those two, so that eliminates 6 there. 5 is one of those two, that eliminates 5 there. We want to check where 5s are. Hmm. 7 cannot be here. Cannot be here because of Knight's move. 8 is one of these two. This is 1, 3, and 5 here. Seven is one of these four, but that's not helpful. Hmm. Let's see. Um, 9 is one of those two, but we don't know which. 7 is one of these three, but we don't know which. Cannot be here or here, but it could be any of the corners. This pink cannot be here, but it could be any of these two or that one. The pink cannot be here. The orange cannot be here. Hold on. Ones. One could be any of those three. One could be any of those three. One cannot be here because of Knight's move. One cannot be here because of Knight's move either. So one is one of those six. Hmm. Four is one of these three here. Four is one of those two here. I'm just bad at Knight's move. I've acknowledged it many times. Apologies if this is slower than you were hoping for. Um, 3 cannot be here because of knight's move. So 3 is one of these 2 cells here, which means this cannot be 3. 3 is one of these 2 cells here. And then it's one of those 2 cells there. Okay, so done 1. One has to be one of those 3, but it's still wide. One has to be one of those 6. One's one of those 2. So one cannot be here. One could be any of these 3. This sees both of these, though. So that's 1. 2's, we know it's one of those 2. We know it's one of those 3. Ah, this can't be 2 then, because it sees all 3 of those. That doesn't help us much right now, but whatever. 2 could be any of those 3. So, oh, this can't be... No. This still could be 2. Hmm. 2 is one of those 2, but that's not helpful because it just eliminates those 2. So that's 2's. 3's, again, cannot be here. Has to be one of these 2 now. It's one of those 2. Then it's one of those 6. So 3 is one of these 2 here. Not helpful. 3 is one of these 3. 3 can any be of these, can be any of these 4. We have 4's. 4 is one of those 2. 4 is one of these 4. 4 can be here or one of these 3. That's fine. 4 is one of those 2. 5 is any of these. 5 is any of these. 5 is any of these. So 5 has to be one of those 2. 5 can't be here. 5's one of those 4. 5's one of those 3, which means this cannot be 5 because it sees all the 5's in box 2. So 5 could be any of these 5. That's pretty broad. 6's. 6 is one of those 2, which eliminates 6 there. 6 is one of those 2. Which eliminates 6 here and 6 here. 6 is one of those 2. Um, 6 can be one of these 5. 6 is one of those 2, which eliminates 6 here and 6 here. 6 is one of those 4. What about 7? 7 is one of those 2. Which has to be one of these 5. 7 is one of those 4. 7 is one of those 6. 7 could be 2 here and this one. 7 is one of those 3. Which doesn't help much. 8's. 8 is one of those 2. 8 is one of those 2. It's simple. And 9's. 9's one of those 2. 9's one of those 3. 9's one of these 4. 9's one of these 3. Hmm. 9's one of these two. Oh, so 9's one of these three. 9 cannot be here. And it can't be here because of knight's move. So 9's one of those two. 9 has to be one of those three here, which means the 9 in boxes 6 and 9 have to be in column 7 and 9, which eliminates 9's in the rest of the column. Therefore, this cannot be 9. So 9 has to be one of these two. Since 9 is one of these two, that eliminates 9 in these two cells, right? Because 9 can't be here because of the two 9's have to, one of the two 9's has to be here, which both see that cell. Both of these 9's then have to be here, which eliminates 9 in these two cells. Wow, that was a lot of deduction there. Because this 9 sees that one from normal Sudoku, that one from Knight's Move. This 9 sees this one from normal Sudoku, and that one's from Knight's Move. So neither of these can be 9. It's a 5, 6, 7 triplet, which eliminates 5, 6, and 7 from the rest of the box. This can't be 7, and this can't be 6. So we have a 1, 2, 3 pair, which eliminates 1, 2, and 3 from the rest of the column. Therefore, this can't be 1, 2, or 3. This must be a 6. And this cannot be pink. That makes this, the pink's a 5. And the orange is a 6. So this is 6. This cannot be orange then. This must be the orange. So this can't be orange. This is the orange. This can't be orange. This can't be pink anymore. This has to be the pink because this 5 eliminates that 5 by Knight's Move. So that's a 4. This is a 5. This is not a 4. This is a 2, 7 pair, which eliminates 2 and 7 from the rest of the column. This can't be 2, so this is 1. This can't be 1. This can't be 1 or 2. It's a 3, 4 pair, which eliminates 3 and 4 from the rest of the box. Therefore, this is 7. This can't be 7. This can't be 4 or 7. This can't be 5. Five cannot be here, so this is the 5 here. These can't be 6 anymore. And we know this can't be 7 because of that 7. So this is a 5. This is a 7. This is not pink then. This is the pink. This cannot be 5, 6, or 7 here. This can't be 7. 7 cannot be either of these two, so 7's one of these. This can't be 1. This can't be 1. This is a 9, which makes that a 7, which makes this a 1. This can't be 6 or 7, so this is 8, which means this can't be 8. This has to be an 8. There is no 8 here. We have a 3, 9 pair. We have a 2, 7 pair. We have a 3, 4 pair. We have a 2, 6, and a 5, 9 pair here. Let's see. Where is the only 9 possible? Okay, this 9 means this can't be 9, so this is 5, which makes that a 9. Therefore, this can't be 9. Where is the 9 in column 8? It must be here. These can no longer be 5 here. We know one of these is a 7. They both see that cell, so this can never be a 7. This cannot be a 7. It can't be 3 or 6 because of a 3, 9 pair in the row. So this must be 1, which makes this a 4. This 4 makes this a 2, which makes that a 1. There's no longer a 1 here or here. This can't be 1. So this must be a 1 here. This can't be 4. We have a 3, 9, 3, 9 pair. This can't be 8. So this can't be 1. Where is the 1 in row 2? It has to be here. This can't be 1. This can't be 5 because of Knight's Move from that 5. Where is the 5? It has to be here. Which means this can't be 5. We'll remove the coloring, actually. We don't need those colorings at least. Okay. What do we have here? One of these two is a 7. We already knew that, so that eliminated that 7. Uh, 3 or 4 is here, which means this is 2, 6, or 8 here. We don't know which one. So again, we have all the 1 set. Do we have all the 2s? We do not. Um, 3s? We do not. Not even close. 4s. This is a 3, 6, 7 triplet, so this has to be a 4, which makes this a 3, which makes that a 4. This can't be 6 then. I think that's all the 4s, right? 1, 2, 3, 4, 5, 6. Yeah. Okay, so then we have 3s. That doesn't help still. We did all the 4s. What about the 5s? The 5 is... Okay, this can't be 5 because of Knight's move. Therefore, it's a 3, which makes that a 5. That 5 eliminates that 5, so this must be a 5, which means this can't be 5. So this is not the blue. Therefore, since this is 3, this has to be 9, which makes this a 9. Therefore, this is a 3. We can remove the blues, I guess. That makes this a 7, which makes that a 6. This can't be 6. This can't be... This has to be the 9 because there's no other place for it in box 6. So this is 9, this is 2. Which makes that a 3. Which makes that 7. I don't know what that is. This can't be 7 anymore. I guess we got a new clue? No. Oh. No, it's just the library. Okay. Need a reset here. Okay, this 7 means this can't be a 7, so it's 6, which makes that a 7. This 7 eliminates this 7, so this is a 2, which makes that a 7. This 2 eliminates that 2, so this is 6, which makes that a 2, which makes that a 3, which makes that a 2. This 6 makes that a 3, and therefore that's a 6. Okay, so we've cleared the factory. Now we have to figure out what we're missing here. Okay. I don't see anything different here. Oh, this is a knight's... Or, I see. That's a German whisper line. So this has to be a 1. Which means 1 cannot be any of these. This can't be 1, therefore it's 2, which makes that a 1. This 2 eliminates that 2, so it's a 5 here. Aha, and that's a black Kropke dot here. This can no longer be 5. 5 can no longer be here or here. 5 has to be here. Because this can no longer be 5. Therefore, this is a 5 here. This is 4 or 6, which has to be in a 1 to 2 ratio with 2 or 3. So this can't be 1. We already knew that. These can't be 3 anymore. These can't be 3. This is a 2-4 pair because of this 3. Hmm. We know this is a 4-6 pair here. There has to be a 3 here. Do we have another German whisper line somewhere? Not that I can see. I forgot how I cleared out this part. This I feel was different. Um, yeah, but I've never been very good at anti-knight synergy or knight's move, however you want to call it. I just don't see them well. I don't even know if there's just a way of actually seeing it better. I just don't see them at all. Maybe you just have to do enough of them. I don't know. To the horseplay in the factory, all knights' moves are strictly prohibited. This is 569. If this is 7, this would have to be 2 here. Oh, we have a 4-5-7 triplet here. Right? None of these can be 1. This can't be 1 because of this one. This can't be 1 because it sees one of these, and one of these has to be a 1. This can't be 1 because of that one, so this has to be 4-5-7. It cannot be 6 here because of this is 6 and one of these is 6. It can't be 6 here because of that 6, so one of these is 6. So therefore, this is a 1-6 pair here. So we can remove the outsides here. We have a 4-5 pair here. 2 can be next to 7, 8, or 9. This is a low then. It's 2 or 3 next to 8 or 9. We know the 5 is one of those 3. We know the 8 is one of those 3. This is 1 through 7 here. But it cannot be 7 because one of these is a 7. One of these 6 is a 7 here. Sorry, 5 is a 7. How did I solve this? I forget. We still haven't found the boss. We know this is a high. We know these two are highs, obviously. Hmm. This cannot be 9. One of these 2 is a 1. Hmm. If this is 7, this would then be 2. So we would have 135 here. Which would make this 7, therefore this would be 1. So if this were 7, this would be 2. This would have to be 135, which would force this to be 7. This would be 1. Therefore, this would be 4 or 8. 4 or 8. Actually, there's no place for... Oh, there should be a 6 here. Possible. I guess, yeah. I eliminated 6x because I thought this one of these two had to be 6, but that was incorrect. One of those two is 6. Hmm. Hmm. I'm gonna pause this right now because I need to, well, need to go to the bathroom. I'll be right back. And I'm back. Okay, let's continue. Okay, where were we? Yeah, we were trying to figure out grid 2. Um, so if this was 7, this would have to be 8. So this is 7. So 8 could be one of those 3. Hmm. This can't be 1 because of this one here. Hmm. We have 1, 2, 3, 4, 5, 6, 7, 8. Because this had to be 9, right? So that's fine. Because of that, this is 5. This has to be the sum of that. It can't be 1. It has to be 2 and 3. Therefore, this is 7 and 8 here. I just left a 5, 9 here. Therefore, that had to be 9. Because it had to go all the way around to form that as a 9. We had 5 here. Hmm. This became... Right, so this had to be 5. These numbers had to be the way they are. This had to be 9, and this had to be 6 already because of the 1, 5. Um, Therefore that left, where's the 1? It cannot be here, it has to be here. Whereas the 4 had to be here. This was 6, 7, and 8. But this could never be 1 or 4. And it couldn't be 2 because of the 2, so this had to be 3, which forced this to be 8. This was 6 or 7 with 6, with a 1 there. This cross was interesting. I'm pretty sure, yeah, this had to be 3 and this had to be 8. Because if one of them was, you can only have so many ones, right? So 2 can't be here. This is a 1-3 pair. You could have... Okay, so this had to be 4-9 because of the 1 and the 3 here. So this was definitely 4-9. We don't know about the 8. This was essentially... you could not have 4 here, so this was 1 or 3 in that area. This, since there was a 9, it had to be with a 6 if this was a low. If this was 2 highs, you could have 1 and 3, right? That's possible. But you had to have one of these be here. Um, okay, so how did we figure out this was 3 and 8 is the question, right? Um, okay, so let's clear all these again. Okay, let's see what we can do with that logic here. I'm curious what that logic was, essentially. Um, let's do the large stuff here. Okay, we didn't know any of these. So we didn't know these. Okay, so we did know this 8 had to be 2 and 6, so that's fine. Okay, so we knew... What did we know? We knew all of these, all the upper 3 boxes, except this was essentially 6, 7. This is 5, 6, 7, 8. Either of these could have been 8. 5 could not be here because of that. This could not be 3, right? Okay, so if this is a low, it had to have a 1, right? It could never, because one of these could only be 6 at most. So, if you had one of these as 6, that would leave, so say one of these was 6, right? That would leave a 1 here. If this was 6, that would force this to be 1, but that would eliminate 1 here. If this was 6, that would force a 1 here, which would eliminate 1 here. So I think the thing was... Alright, so this was interesting. So if this was a low, 1 can only be here because 6 would have to be here, right? But how do we know a 3 was here was the question, right? 3 technically could have been anywhere here. Hmm. I don't know what hidden puzzle I got, but... um... But this could have been like 7 and 8, right? Possibly. How do we know it was 3 and 8? Okay, yeah. If this was 1, it would have to be with 6. And then the problem is this would have to be 7, and that would be 3. So 1 could never be here, right? Um, So the combinations of these were specifically, if this was low, it's 1 and 3. If it's a high, it's a 6, right? If this is 3, this would have to be next to a 8 or 9, but neither of this could be 8 or 9. So this cannot be 3 here. This is a 1, cannot be 6, so it's 7 or 8, and this is 1, 7, or 8, too, right? But if this were a 1, it would be next to a 6 here, which would force this to be 1, and that would be a contradiction, so this can never be 1. If this was 7, that would be next to a 1, which would force that to be 6, and therefore this would have to be 8, but that would be a contradiction too. So this can't be 7. Therefore, this would have to be 8. This could not be 8 here. This would have to be 8. So we got that from there. Okay, so, but the question is, we know this is 1, 7, or 1, 6. One of these is 1, so this cannot be 1. It cannot be 6 here, because it has to be 5 away from 8, so therefore this is a 3. That's how we got that. Okay, and then we saw both of these go into here. Um, oh, Okay. So since this was 3, we had a 4, 5, 7 triplet here. This had to be high, and this had to be high. And it could not be 2, 4, because that would force this to be a 9 here, and we already have a 9 in the column. So we know these both had to be high. Okay, sorry, yeah, if these were low, that wouldn't be the case. So this has to be high, this has to be high. So we knew what? This was high, this was high. It would have to be next to a low, which would have to be a 1, because it could not be 2. And one of these is at least a 7, because 8 is here. So this is 1. This cannot be 8 or 9, because of the 8 or 9 in the columns. So this would have to be 7, because it's between 2 unique digits, which forces this to be 2. This 7 means this can't be 7, so this is 6, which makes that a 7. 2 cannot be here. This became a 4, 5 pair here. This one of these is a 1, so that eliminates 1 here. 1 is also eliminated here. Since 1 can't be here or here, 1 has to be one of these 3. Because it can't be here, because it would see one of those 2, and one of those has to be a 1. Again, this can't be 1, then one of these 2 are 1. 6 cannot be here. 6 also cannot be here. Why can't 6 be there? I'm not sure. I don't know, actually. We do know this is a 4, 5 pair. This can't be 5. 2 is here. So 2 can't be here, 2 can't be here, 2 can't be here, which forces 2 to be here. So 2 has to be one of these 2. 3 also has to be one of these 2. So that's why it's a 2, 3 pair, which eliminates 2 and 3 from the rest of the box here. But this could still be 6. So I don't know. Okay, so we're not guaranteed that... Oops. One of these could be 6, actually. So I don't know if this is 6 here. This could be 6. 7 cannot be here. So this has to be a 7 here. This still could be 4, 5 here. But this can't be 1, 2, 3, 6, 8, or 9. So this is... It can't be 7. So this is a 4, 5, which eliminates 4, 5 from the rest of the box. 9 has to be in a specific spot. It has to be here, which makes that a 6. Right, which leaves a 5, 6. Okay, so that's how we got there. This can no longer be 6 then, which forces 6 to be here, which means none of these can be 6. Therefore, it's a 4, 5, 7 triplet. Okay. Hmm. If this is 7, this is 2, this is 8, this is 7. Huh. 7 and 9 are both here. This can't be 2 or 3 here. So if this, I think I did something like this. If this were 7, this was 2. This would be 8, this would be 7, which would make that a 6. There'd be no 6 here, there'd be no 7. This would be 5. This would be 9. So this would have to be 6 if that were the case. Right, so this could not be 6. 2 could not be here. 7 could not be here. It's a 1, 3, 5, which forces this to be 7. That's a 1. This is a 6. This can't be 3. This is 2. This is 3. This is 2. This is 3. So that seems okay. This is a 1. We have 6, 7 already accounted for. This is a 4, 8, 9 triplet here then. Ah, 7. No, it's 2. 2. Huh. So this can never be 8 or 9 here. Right? We tried this. Well, Right. We tried the 7 here, which makes this a 4, 8, 9 triplet. This seems fine, though, actually. Hmm. Uh, that seems fine. Okay, so that was if this was 7. If this is not 7, obviously it becomes an 8, 9, 8, 9 pair here, which means this can't be 8 or 9. So this can never be 8 or 9 here. Okay, so if we have an 8, 9, 8, 9 pair, um, hmm. So if this were a 3, that would be 8, 9, 8, 9. Therefore, this would be 2, which would force this to be 3. That would be 2. This would be 3. This would be 2. Uh, let's see. Where else do we go from here? Um, hmm. I don't remember how I solved this. I do remember it was something like this. Like I had to logic out something here. but I don't remember what it was. Hmm. 3 seems to work okay with 8 and 9. 1 of 1 or 7's here. 1 of 1 or 7's here. Maybe it involved the 1 and the 7? But that seemed like it worked fine. Hmm. Okay, let's go back to this being 7. Make that 8, makes this 7. Means this is not 2 or 7. So we have a 1, 3, 5 triplet here, which forces this to be 7, 1, 6 here. There's no 6 here. There's no 1 here. This is 1, this is 6. This has to be 7 here, which forces this to be 6. This is 5, which forces this to be not 5 or 7. It's 9. This has to be 6. This is not 2. This is not 3. This is not 2. This is not 3. No 6 or 7 here. No 6, 7, or 1 here. This could not be 2. This could not be 2. This could not be 7, so this would have to be a 7 here. There's no 6 here. This can't be 6. This all seems fine. 4, 8. Hmm. This seems fine. Hmm. So again, if this was 3, this was 8, 9. That would force 3 not to be here, so 2 would be here, which would mean this is 3, this is 2. This is not 2, this is not 3. This would not be 8 or 9, this would not be 8 or 9. Maybe that's not the right approach. What happens if this is 6? If this is 6, this is 1, which forces this to be 1. This can't be 1. There's no 6 anymore here. This can't be 1. So 1's one of those two. Oh. This 1 means this can't be 1. Therefore, the 7 has to be here, which means this can't be 7. So this has to be 6. This has to be 8 and 9. Which means this can't be 8 and 9. This can't be 8 and 9. This can't be 6 here. 7's here, so this can't be 7. This forces this to be a 1, which means this can't be 1. This becomes a 1 then. 8 and 9, 8 and 9. be 4, 6, 8, 9, 8, 9. This could not be 6, so this would be 6 there. Huh. Okay. That's interesting. So either this is 6, which forces this to be 1. That would be 1, which would force none of these to be 1. So one of these two obviously is a 1. If this is a 1, that eliminates 1 here, which forces that to be 1. So if this is 1 and that's... one of these two is 1, right? Actually, both could be both. One of these two is a 1. We tried it if there's a 1 here. The 1 could be still be either of these because it could still be either of these two, right? Because that would be 1. But if 1 is here... Sorry, if 1 is here... No, that was if 1 was there, right? So if this is 1, this is 7. 1 could be either of these because this is 1. This is 6 either way, right? Okay, maybe that's it. Right. So this is 6 or 7 here. Right, because it cannot be 1, 4, 2, or 3 because of the 2, 3 pair in the column. Can't be 5 because one of these two has to be a 5 because this cannot be 5 because of this 5 being here, and this is on a German whispered line. So 5 has to be one of these. So this has to be a high. If we try to make it a 7, that makes this an 8, which makes that 7. Therefore, this is 6 because it can't be 5 here. Which means this can't be 6 or 7. This has to be 5. This has to be 9, which forces this to be the 6. Okay. Then, if this is not... So that's... If this is... That's if this is 7, this has to be 6, right? If this is 1, that's the interesting part, right? If we had 1, this is 6, this is 1. That means 7 is here, which means this can't be 7. This becomes an 8 and 9 pair. 7's here. This has to be a 6 either way. Right? So again, this is 5, 6, this is 6 or 7 specifically. If this is 7, this becomes a 6, which means we cannot have a 6 anywhere else in column 6 except here. So that's a 6. If this is 1, this is 6. This becomes 7, which makes this an 8, 9, 8, 9 pair, which forces that to be 6. So either way, this is a 6. That's probably what we've had there. That's a 6. This cannot be 6 here. So 6 cannot be here, or these two. We knew 9 had to be one of those two. 9 could be any of these. This can't be 6 either. Right? Because again, 7 forces this to be 6. Because it can't be 5, it can't be 1, 2, 3, 4, it can't be 8 or 9. If this is 1 and 6, that forces 7 to be here, which forces this to be 8 and 9 pair, which means this is a 6 still. So this can't be 6, which means that's a 6. Okay. Hmm. So this can never be 1. If this were 1, that would force this to be 6, which would force that to be 1, which eliminates 1 here, which would force that to be 1. So this cannot be 1. Okay. Hmm. Um, 4 is one of these two cells. We're not sure which. We just know that it is. Uh, so if this were a 5, this would be 7, this would be 8, 7. This would have to be 9. This would be 1. This would be 6, 1. So far it looks okay. This would be 9, which would force this to be 8. That would force this to be 4, which would force that to be 8. We have no 8 or 9s here. This couldn't be 7, so this would be 4. This would not be 4. 7. So no 1s here. We have a 2 or 3 with a 5 and a 7 here. This would be 6. So this could not be 6. This could not be 8. This could not be 4. So this is 1 or 2. Still seems fine. This could not be 6 anymore. 9 with 5 or 7. So this could not be 9 then. This couldn't be 1. This couldn't be 1, so this would have to be 1 if that were the case, right? 6 and 1, 2, 4, and 8. 8 would be here, so this would not be 8, therefore that would be 8. This could not be 4, this would be 2 then. Which would force that to be 4, which would force that to be 3, which would make that a 2. This 3 would eliminate 3 here. There would be no 2s here. This could not be 2. So far, this is fine. This couldn't be 4. This couldn't be 4. This would be 5, which would make that a 4. This would be 7. No 5, so that would be 3. No 3 or 5. No 5. This would be 4, 6 pair. No 4. 5, 7, 9. 5, 6. 4, 6. This would be 9, so this would be a 5, 7 pair, which would force this to be 6. This would not be 6. We'd have 5, 9, 5, 9 pair, which eliminates 5 and 9 from the rest of the row. This is a 2, 3 pair, which forces this to be 5, 7. That seems fine. Yeah, that seems fine. Hmm. This is tough. Okay. Hmm. It's tough to remember what you did previously sometimes. Uh, hmm. Hmm. Both seems to work okay. Hmm. Hmm. Okay, if this is 1, this becomes 7, which forces this to be 1, which makes that a 6. This one eliminates, whoops, one of these is a 1. This can no longer be 7 here. This can't be 7. This is 5 and 9, which means the 7 in this column, it could be any of these. 1 is one of these two. This is 1. We have 2, 4, 6 here, so none of these can be 6. Ugh. This seems kosher too. Hmm. This can't be 9. We have a 7, 8, 7, 8 pair. Hmm. Uh, yeah, that seems fine. Uh, wish I remembered how I solved this. Hmm. This is a separate grid. Hmm. We know this is 3. So the rest, well, this doesn't help, right? Oh, this cannot be 2, 4. Because that eliminates all possibilities for that cell. So this can't be 2, 4. This becomes 3 and 6, which makes that a 4. This 4 means this can't be 4. It's 2, which makes that a 4. None of these can be 2. This can't be 2 or 3. This is a 1, which makes that a 2, which makes that a 1, which makes that a 3, 6. This is a 2, 3, and 2. Aha. I don't think we solved it, though, anymore this way. I don't even know. Right. So this is... Right. 2, 5, 7, 8, and 9 left. These can only be 2 or 8, which is next to a 4 on with black crop key dot in between. Okay, and yeah, this was okay, so alright, this was the skyscraper stuff. Did we unlock the clue first? Did we unlock that rule set yet? No, I don't think so, right? Wait, did it just reset? That would have made me very sad and or angry. Okay. This cannot have a 4, it cannot have a 6. This has to be a 1-2 pair. Okay. Right, no 2, 4, no 4, 8, no 3, 6. It has to be 1 and 2 here. Which means this is 1, 2, or 4, cannot be 1 or 4, so this must be a 2, which makes this a 1, which makes this a 2. This cannot be 2 anymore. 2 can only be next to 7, 8, or 9. We have a 3, 6 pair and a 4, 8 pair here. So this, one of these is 6 or 8. So we have 3, 4, 6, 8 amongst these. 5 cannot be on a German whisper line, so this can't be 5. This becomes 7 or 9. This is 7 or 9, and this is a 5 here. 7 or 9 can only be next to... It can only be next to... 9 next to 3 or 4 here. So this is a 9, which makes this a 7. 3 or 4 is here, which forces this to be 6 or 8. 6 or 8 can only be next to 3 or 4, but it's specifically 3. So this is 3, this is 8, this is... it's not 4. This is 4, and this is 6. So 7 cannot be here, therefore 7 must be here. None of these are a 7. This can't be 2, therefore this is an 8. None of these are 8. I don't think we got the extra rule yet, right? Oh, we did. We get the Scribekeeper clues, where count the number of digits seen in the indicated directions, row, column, where digits obscure any subsequent smaller digits. So this is 1, 2, 7, 8, 9. Okay. This, if this is higher than 4, it would only see less than 5 skyscrapers. So this is a 3 here. This is 3. The remaining digits here are 5, 8, and 9 in column 1. This sees 7. So if there were 4 in one of these two cells, the problem is that it would see... Right, if there's a 4 or higher in any of these cells, it would see less than 7 skyscrapers. One of these is low, so one of these is 1, 2, right? One of these is low. It could be 4, right? But if this is 4 and this is 9, okay, I remember this logic here. If this was, so if this was 4 and this was 9, it would only see 6 skyscrapers at most, because you see these 5 and then the 9, and then it could not see any of these. But it sees 7 at least, so this cannot be 4. Therefore, one of these is a 1, 2. So, the point, though, is this cannot be both 1 and 2 here. Therefore, it cannot be, one of these has to be seen, and then it will block the 3. The only way that can happen is if this is 4, it will see 5, 6, 7, 8, and 9 in order. And this has to be 1 or 2, right? Right, because again, if you see something higher here, it can't be. It has to be 1 or 2 here. But it could see a 4 here, right? We try to have a 4 here, but it can't work because that would be 9 and would see 6 skyscrapers only, which means it sees 7. So 4 cannot be here, therefore the other 1 or 2 has to be here. Therefore, if this is 1 or 2, this sees 4 and must see 5, 6, 7, 8, 9 in some sort of order. So this would be 4. This would have to be 5, 6, and then one of these is a 7. And then you would see 8 and 9 in order. So this could no longer be 9 here. This can't be 7, so this is a low, which forces this to be 7. So this is 7, it's next to a 1, 2. This is a 1 or 2. 6 cannot be here. 1 can't be here. So what are the remaining digits here? We have 1, 5, 6, 7, 8, 9, right? This can't be 1 or 8. No 1 or 8 here. This can't be 5. This can't be 5. There's no 7 here. There can't be 5 or 9 here. We have a 1, 6, 8 triplet in box 4, which eliminates 1, 6, and 8 from the rest of the box. This can't be 8. This can't be 6 here. This sees 7 here. So it sees 6 at least. So it sees 3, 4. It won't see this one. It cannot have a 9 in one of these spots. Okay, what are the remaining digits here might be a good point. 1, 2, 3, 4, 8, 9. 1, 2, 3, 4, 8, 9, right? 8 can't be here, though. If this were 8 or 9, it would only see 1, 2, 3, 4, 5 at most. So this cannot be 8 or 9. It can't be 3 or 4. This is a 1, 2 pair, which eliminates 1 and 2 from the rest of the box and the column. So this is 6 or 8. This cannot be 8, though, because if it's 8, that would only see 4 digits, 4 skyscrapers, or skyscrapers. What is it called? Skyscrapers. Which forces this to be a 6, which means this can't be a 6. We have a 1, 8, 1, 8 pair here. This is a 3, 4 pair, but this can't be 4 because of this 4, so this must be 3. This must be 4. We have a 6 with a 5 or a 9 here. We're not sure which one. So this must be 5, 8, and 9. So 5, 8, and 9, 5, 8, and 9, 5, 8, and 9. This can't be 5. This can't be 9. If this were 9, it would only see 5 digits, so this cannot be 9. Therefore, we have a 5, 8, 5, 8 pair, which eliminates 5 and 8 from the rest of the row. So this is a 9. Okay. We have 8 is one of these two. This becomes a 1, 2, 5, 7, 9 quintuplet in box 2. This sees 6. 9 cannot be last, though. So 9 has to be one of these two. Five, 8. This sees 6 also. These digits cannot be 1 through... Can it be 6? No. So it's 1 through 3 here, right? This can't be 3. We have a skyscraper here, too. Okay, so this skyscraper says that we see 6 this way, so this cannot be 8, because then we'd only see 5. So this is a 5, and this is an 8. Okay. Right, I remember this vaguely now. Okay, so... None of these can be... Okay. What are the what were the possibilities here? You can't have 5. You could have well, 5 can't be here. You cannot have 6 in either of these places. If it's 6 here, that sees 1, 2, and then 6, it sees 1, 6, 7, 8, and 9, which is 5. So 6 can never be here. This has to be 1, 2, or 3. What about these? This can never be 6. It could be up to 4 here. Whoops. This would be 1, 2, and 4 then. This cannot be 6 because then it would see the first skyscraper, then 6, 7, 8, 9, which is again 5. So this is 2 or 3 here. This could be 6, right? It could be 1, 2, 6, and then 7, 8. Okay, 8 cannot be here. Never mind. 8 can't be any of these cells. So 8 is one of these two. Because of that, this can never be 6. Because the problem is it would have to have 7, 8 here that it sees. So this is also 1 through 4 here. We need to see... We can see at least 4 digits here. We need to see at least 1 digit here, which means one of these digits is at least one of these digits is a 6 or 7. Same here, though. This sees at most 3. This sees 4 and 5. We need to see at least 1 digit here, which is from 5 through 6. So one of these has to be 6 or 7. One of these has to be 6 or 7. So this then has to see both of these because it sees 1, 2, 3, it sees 4, it sees 5, it sees 6, because it cannot see both 6 and 7 here. And 5 can't be here because this is 5. So, because of this, this is 1 of 6 or 7, this sees 1 of 6 or 7 this way, therefore it must see both of these. Therefore, this is a 2, and this is a 1, which forces that to be 2, this to be 1. We see the boss. This must see all of these 3, so this cannot be 4 here. This can't be, this has to see these 3 and then one of these. So this sees 1 of 6 or 7, and the 3 must be here. This sees 6 or 7. And it has to have 1, 2, or 4, and the remaining of these digits are 1, 2, and 4. But this can't be 2, this can't be 2. Okay, so this can't be 1 or 2. This can't be 2. No 2, no 2, no 1. 3 has to be one of these 2 digits. One of these is 6 or 7, so one of these has to be 6 or 7 with it. Therefore, this is a 3 here. And this is 6 or 7 specifically here. I can't tell what that is. Anyways, okay, we have the boss, right? So I've done this before. I don't remember what happened. Anyways, let's continue. Okay, you still feel a little lost after your brief attempt, right? Climbing atop the castles was a good idea. Black Kropki, arrows, skyscrapers, and Sudoku. Okay. I vaguely recall this. Wow, these are hard to read. I think that's a 2, 2, 3, 3, 3, 2, 2, and 3. That's really hard to read. Um, anyways, right, I remember this was 1 through 6, obviously. But this sees only 2 skyscrapers here. This sees only 2 skyscrapers, which means the largest of them must be here. And you cannot have a 5 here. So this can never be 1 or 2, because that would be less than whatever this is, right? So one of these must be a 6, right? Because, well, one of them's 4, and the other one has to be a 6-3 pair. This can never be 6 or 5, because then that would see greater than 2 skyscrapers here. This can never be 6 or 5. It can never be 4 either, right? You have to have at least 2 digits from 1, 2, and 3. So same here. This is at least 2 digits from 1, 2, or 3. So this has to be 6 through 9. 6 through 9. This... This sees 2 skyscrapers this way. And 3 this way. There are 2 here. There are 3 this way. We know the 8 cannot be in between here. So the 8 has to be one of these cells. I think that forces the 8 to be here, right? The 8 is always going to be in between the this skyscraper seeing this way. So this skyscraper always sees the 9 next. So the 8 could not be in between here. Therefore, where is the 8? 8 has to be in between here and the skyscraper and the 9. So therefore, this is the 8. So this is 8. You could have any of 9 here. So 9 could be here or it could be here, right? So 9 can never be one of these 2 cells, right? If 9 is one of these 2 cells, then the problem is there has to be a 7 in between one of these 3 cells here, right? Does that work? Yeah, I can't remember quite what my logic was here. This was a while ago. This has to be, one of these is the 3-6 pair, and then the other's 2 and 8. I'm not sure which. So it could be 4, 1, 3. That's possible. You could technically have a 9 here if a 7 were, if the 7 were here. This is 9 and this is 6. Okay, let's look at the arrows. All right, arrows suppose, can this ever be 9 is kind of the question, right? Okay, look at this and this. Can this ever be 3? If this is 1, 2, 1, 2, this would be 6. I guess that could be 9, technically. Um, there's no 3, 6, or 4 here. 3, no 3, 4, or 6. So this is 5, 7, 8, 9. This is 5, 7, 8, 9. This was what, 1 through 7? I think for these. But obviously this can't be 5 or 7. This can't be 5 or 7. This is 1, 2, 3, 4, 6. This could be 1, 2, 3, 4, 6, 8. This is at least 3. It sees 3 this way. So 9 is either here or one of these two in row 7. 9 could be any of these 4 in row 3. Nine cannot be any of these 3 in column 6. It cannot be here. 9 could technically be here, or it's one of these 3. Hmm. It's been a while since I did this part. Let's see. Okay. If the 9 is any of these. Okay, say the 9 is here. If the 9 is here, that would mean the 9 has to be one of these two, right? That seems feasible. Wait, can this ever be 5 for either of these? I don't think so, right? If it's 5, it would have to be 1, 4, which would make this 2, 3, and 4 at minimum, which doesn't work. Or it's 2, 3, which eliminate, and we would have 4 digits that would be from 1 through 3 in this box, which is not possible. So that's not possible, and this is not possible either. So it's 7, 8, or 9. Um, 8 cannot be here. If this is 8, that would force this to be 9, which is possible. So you could not have a 6 in either of these. It would be 3, 4, 3, 4 with 1, 2, 3. Hmm. If this were 9, that would mean 9 is not here, which means 9 could not be one of these, so this could not be 6. And I think that breaks then, right? If this were 9, 9 has to be one of these three, because it can't be here, can't be here because of the skyscraper rules. Can't be here because of arrow, can't be here because of arrow. So it has to be one of these, therefore neither of these can be 9, therefore neither of these can be 6. So since this can't be 6, it has to be 3 or 4 with 1, 2, or 3. This would not be a 9. Therefore, we'd see a 3 or 4 here, because this could not be 9 here. And 6 can only have a 9 in the arrow circle with 1 and 2. So then this would be less than... This would be either 3 or 4 with 1 or 2. 9 could not be here. And so we'd see a 9, we'd see 3, 4. We would not see these, but one of these threes is greater than 3 or 4. Guaranteed. So we'd see greater than 2. So this can never be 9, which means 9 is here, which means this cannot be 9 here. So this must be 6, 7, or 8. This has to be a 3, 4 pair here, which eliminates 3 and 4. One of these is then a 6. We know a 9 is here. This is 3 or 4. Similarly, so this can't be 9, this can't be 9, because if one of these two were a 9, you would guarantee to see more than 2 skyscrapers here. Same here, this can't be 9, because if this were 9, you would guarantee to see more than 2 skyscrapers here. So there has to be a 9 in here or here, in here or here, right? Because otherwise, you would not see... So if this is... One of these is 3, so the other one has to be 1 and 2. So therefore, this must be... One of these must be a 6. To be able to see... And it would be 3, 1, 2, you'd see 9. If you had 4, you would have... Okay, so this is always 1 here. This is always 1 here, right? Because you always have 6, 7, or 8 added up to by 3 unique digits. Therefore, you have at most 8, which would be 1, 2, 5, and 1, 3, 4 at best. We don't know if it's 7 or 8 with it, though. So either this is 9, or it's 1. It has to be 1. It can't be 1. It's 2 or 3, right? This is 2 or 3, or this is 9. Either way, you can't have 1. If it's 3, you see 1, 2 here, and you would have to have a 9 here, which would force a 9 to be here. If this would then be 4 with 1, 2, or 3, and the other 2 or 3 would be here, and that would be 9. So you could not see 2 or 3 here. You cannot see 1, 2, or 3 here. This is at least 4. This is at least 4. So this is... What do we see here? 6 is here, 6 is here. Therefore, 6 must be one of these 3 digits here. This is at least 4. So the other digits can only add up to 5 at most. So this cannot be 6. This cannot be 5 or 7. No 5 or 7 here. No 6 here. Because this is at least 4, 5, 6, or 7. This cannot be 8. 8 could be here. And I guess this could be 7. That's possible. This could still be 9. Hmm. Hmm. Okay. Cannot be. It could be 7 if it's 2 and 5. That's possible. These 5 digits equal these 2 digits, but these 2 digits could add up to 17. We know there's no 1 there, though. 1 has to be here, 1 has to be here. Where's the 1? 1 has to be here, right? Because 1 cannot be here because of the 1 already in the box. 1 can't be here because of the 1 already in the box, so this is 1. We have no 3, 4, 6. So the remaining digits. So this... Interesting. This is the other 2, 3, or 4 here, right? If it's 1, 2, 3, you have to have 4, 5 as the remaining digits. So it would have to be 9, right? Um, okay. Can you ever have a 2 here? I don't think so, right? Because if you did have a 2 in one of these two areas, that would force us to be 1, 3, 4, and this would be at minimum 5, 6. So this cannot be 2, therefore this becomes a 2, 6 pair here. Therefore, this is 5, 7, 8, 9 at the edges. But we know one of them has to be 9, because one of them is 1, 2, or 3 here, which would put 4, 5 here. Therefore, this would be 9. So none of these could be 9, because one of these two has to be a 9. The other one could be 2, 5, 3, 5, or 2, 6. So one of these is 4, 5. We're not sure which. The other one could be 2, 5, 3, 5, or 2 through 6, essentially. Um, okay. If this was 1, 2, 3 here, that would require this to be 4, 5. So this would be 9. This would have to be the 7 or 8. But the 5 would have to be on the other side then. So this would have to be 2, 6 if that were the case, right? Which would mean it's guaranteed to be 1, 3, 4 as the other side. So it'd be 8 and 8, I believe. Right? So again, this is okay, we're trying to figure out the logic here, right? If this is 1, 2, if this is 3, this has to be 1, 2, which makes this 4, 5, which makes this a 9. But 5 can no longer be here, so this is 7 or 8. Where is the 5 in column 1? It would have to be here. Therefore, this could not contain a 5. This could not be 9, it's 7 or 8. Well, it would have to almost certainly be 8, right? Because you cannot have a 5. Um, This would be 6. This would be 4. So to add up to 8, you would have to have 2 and 6. So this is 2 and 6 are 4 and 5 in these spots, and this is 8 and 9 and 8 and 9, which would force this to be 5 or 7 and 5 or 7 here. So that works both ways, right? So then this can never be a 3. It has to be a 2. This then would always be 1, 3, 4 if it adds up. So this is a 6, 8 pair here. We have a 2, 9 pair here. Six has to be one of those three. We already knew that. Okay. None of these can be 1, 2, or 3 here. So this is 4 through 9. 4 through 9. 4 through 9. 4 through 8, but this can't be 8 here. Because this can never... Either this is 2, and this is 1, 3, 4, and this is 9. Or this is 9, this is 1, 2, 3. 8 could be here. Yeah, we just don't know with these. The rest of these digits must be 5 through 9, right? Because if they're not, that means, yeah, this is 2 or 4. This is 2 or 4, right? And we have 1 and 3 here. Okay. 1, 3, 4 adds up to 8, which is why this is a 6, 8 pair here. This sees only 2. Hmm. Hmm. I don't remember solving it this way, but anyways, what other skyscraper clues do we, or skyscraper? Yeah, no, it says skyscrapers. Okay, this is 2, this is 3, this is 2, this is 3. Okay, what are the remaining digits in column 4? We have 1, 3, 4, 5, and 7. 3, 4, 5, 7. 1, 3, 4, 5, 7. Okay. Hmm. Hmm. These cannot be 5. If these are 5, the problem is this would be 7. Then what would these add up to, right? This would be 7, which would force this to be 5, which means this could not be 4, 5, so it would be 2, 6, which would make that 8. Therefore, this would be 9, but then this could not be um, 4 and 5 adding up to 9. We know the 4, 5 has to add up to 9. So 5 can never be here and can never be here. Hmm. This digit must always be higher than that. So this is 5, 6, 7, or 8. Because it must see the 9, and it has to see that cell specifically. This must be smaller, so this is 1 through 7. Technically 8 could be here. So, hmm. Where can 8 be in column 6? It can't be any of these 3 cells. It cannot be any of these 3, or I guess it could be here. Dang it. It could be here. So the 8 is either here or here in column 6. Cannot be here because it has to see at least 3 skyscrapers that way. I don't remember how I solved this. This was a while ago. Maybe not for you guys, but for me it is. Though, considering the length of these videos, this might be a long while for you guys, too. Uh... Hmm. 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 This is at least 6. So we have 6, 7, or 9. This is at least 6. I think one of them has to be a 9, right? We know 9 cannot be here. I think one of them has to be a 9. If we had a 6 and a 7 only here, I think that... Okay, so 9 cannot be any of these, obviously. So 9 is one of these 5. I don't think this could be a 9, though. If this is 6 and 7, you have to have 1, 4, 1 here. And then this would have to be 2 and 2 with 5. Yeah, so you have to have a 9 in one of these 2 cells, no matter what. But one of them is a 6 or a 7. Um, can you ever have 171 then? Yeah, no, because you can't have... Oh, 8 can be here, though. So this can never be 2? Doesn't it always have to be 1? Four, four, one could go with 2, 5, and 1 here, which would make an 8. So that is possible. So we are not limited there. Uh, hmm. Hmm. I remember it was something related to these arrows that I was able to figure out something, but I don't really remember what. What are the remaining digits here? This has 4 digits smaller than it, so it has to be 5, 7, or 9 here. Hmm. We have 1, 2, 3, 4, 5, 7, and these could be 9 here, but this can't be 1. What else did we have? Can this ever be 4? If this is 4, we have 4, 4, 1 here, which would force this to be 9. So this would be 6 or 7 at most. This would be 2 and 5 at least, and therefore that wouldn't work here. So this can never be 4. Could be 3, though. You could have 3, 4, 1. This would be 8. Then you could have 2, 5, 2, and that would be 9. Man, I really don't remember this. I mean, I vaguely recall some stuff, but so we see 2 specifically this way, we see 2 specifically that way, we see 2 specifically here. If this is 2, this becomes 8, because it's 1, 3, 4 added up to 8. So it's the 8 and 9, and it would see this specific skyscraper. Then it would see these 2 skyscrapers added together, and that seems fine. with the 9. Must see this over these two. Sees this one, and it sees another one in between. I don't remember how I eliminated these. I don't even remember if this was a 9. Uh, hmm. We know one of these is a 9. We're not sure which. None of these can be 9. Hmm. If this were 9, that would force 8. Okay, so this cannot be 8 here. We know that for certain. That's interesting. This is 1, 2, or 3. If this is 1, it has to be 2. If this is 2, this is 1 or 4. If this is 3, this is 6. So this can never be 3. This can never be 3 for the same reasoning. Now, that doesn't help very much, though. Hmm. Hmm. I remember this did take me a while. I just don't remember how I solved it, though. Hmm. Hmm. This is tough. Hmm. I really don't remember how I solved this. I mean, that is a lot of these things that don't remember a lot of. Hmm. Hmm. It's been a while. Oh, that's interesting. If this is 9, this becomes 4, 5. This is 1, 2, 3, which would force this to be 9. That doesn't tell us anything. Never mind. If this is 8, obviously this can't be 8. Huh. Hold up. Okay. If this is 8, that means this can't be 8, which makes that an 8, which works fine-ish. This becomes 2, 6. This is 1, 3, 4. This is 5. This is 8. Right. This would then be 1. This is 2, 6. This is 1, 3, 4. This is 2. This is 9. So the 8 would have to be here. And therefore the 8 would have to be this one. So if this is 8, this can't be 8, which means the 8 has to be here. So I think one of these two has to always be an 8, right? If we try to have an 8 here, that would force 8 to be here and 8 to be here, which would eliminate 8 as possibilities for these two cells. I don't think I went around it this way. But anyways, we know 8 then has to be one of these two cells, but that doesn't really help much. Mm, mm. Well, it's been 2 hours already, so I think, and it's getting dark here, and I have some other things I need to take care of. So we'll put to a stop right now, and we'll start off this next time on Frank Puzzles. Take care.